GMAT all day.
I believe that divisibility is the single most valuable concept to know for the GMAT. That is because it is the common thread that unites all of the different quant concepts on the GMAT, and divisibility is very intertwined with exponents. And we have already seen that a bit, where we have been breaking up the bases of our exponents into their prime factors, and that allows us to separate out our bases so that anything that can be combined or canceled out will be. And so let's take a look at a problem here, dealing a little bit more with exponents as well as divisibility. If x, y, and z are all integers, are all positive integers less than 100, such that z times 3 raised to the y times 16 raised to the x all over 2 times 3 raised to the y plus 1 times 4 raised to the 3x is equal to 1, which of the following is a possible value of z? And so we have seen this before, where they ask for either the possible values of a variable or what could be true about x. And so that is a hint that there are going to be multiple values for z in this case. And so we probably do not need to solve for z. There probably will not be infinite values for z, which is often the case, because in this case, we know we are limited to integers less than 100. So positive integers less than 100. So I'm guessing we will most likely be limited in our values for z, but we will also probably not be able to solve for it. So what I want to do here is, if they're asking me for possible values for z, I should probably get my equation here in terms of z. Then before I do that, though, I want to make sure it is as simplified as possible. And so I want to combine or cancel out as much as I can. And so I will rewrite this and break up my bases as much as I can. So 16 raised to the x, 16 is just 2 to the 4th. So that is 2 to the 4th raised to the x all over 2 times 3 raised to the y plus 1 times 2 squared raised to the 3x. And so now I'm doing multiplication on the top and bottom. So I can combine these bases here. So I have a base 3 on top and the bottom. So I want to sort of separate out my terms like this. This would just be 3 to the y over 3 to the y plus 1. And then here, the 2 to the 4x, or 2 to the 4th raised to the x, that it is 2 to the 4x, because I multiply my powers when I am raising an exponent to an exponent. Then here I have 2 squared raised to the 3x, that is just 2 to the 6x. This is all equal to 1. Now, if I want to combine my exponents here, so I am dividing exponents with the same base, so I got to subtract the powers. So I have to remember that I'm subtracting this entire quantity. So this is y minus the quantity of y plus 1, like that. So this means my y cancels out. I am just left with a negative 1. So I have z over 2 times 3 to the negative 1 times, and here I have 4x minus 6x. So that is just 2 to the negative 2x. So I don't like working with negative exponents. I convert them into positive exponents. So here I have z over 2 times 3 to the negative first. That is just 1 over 3 to the first. And 2 to the negative 2x. That should be 1 over 2 to the positive 2x. So now this just leaves me with, does have a z up top all over. I have a 2 to the first times 2 to the 2x. So that is 2 to the 2x plus 1 times 3, all equal to 1. So then for my final step, I want to get everything in terms of z. So just move my denominator over to the right side. Z is equal to 2 to the 2x plus 1 times 3. And so I would say this is an expression for z that is fully simplified. And I should be able to answer the question from here. If I wanted to, I could go a little bit further by saying I can sort of reverse engineer my exponent rules by writing this guy here as z is equal to 2 to the first times 2 to the 2x times 3. I'm actually sort of taking a step backwards from what we did here, but then I can combine this 2 with the 3 over here to say z is equal to 6 times 2 to the 2x, which I think I like a little bit better. So I wouldn't say you have to go this far. As long as you get z, some expression for z by itself, you should be able to still answer the question. So now we have to take a step back and think, okay, so what does this mean for z? Remember x, y, and z, and y canceled out, by the way, a long time ago, so we don't need to worry about it, but they all have to be integers less than 100. So z's got to be less than 100, but x also has to be an integer, so don't forget about that. So we're saying z is a positive integer less than 100, but it also has to be, you have to be able to express it as a multiple of 6 times some power of 2. And so to start, we need a multiple of 6. So if we were to have any answer choices that were not a multiple of 6, we can eliminate those. I believe 99 is not a multiple of 6 because that is not even. It's a multiple of 6. It's got to be a multiple of 2. So we can eliminate one answer choice there. So let's think what z could be. And so we are pretty limited because z can be 6 times 2 raised to the 2 times 1. It can be 6 times 2 raised to the 2 times 2. So 6 times 2 squared. That would be 6 times 4, which is 24 here. What does this leave us with? Already here, this is 6 times 2 to the 4th, which is 16. So 6 times 16, I believe, is 96. And these seem to be the only possible values for z, because after this, we're going to be over 100. So in this case, we can solve for all the possible values for z, and we really just need to select the one that is in our answer choices. So 24 or 96. It looks like 24 is our guy. Divisibility is very useful, and everything can sort of be explained in terms of a divisibility problem.